Problem 16. Because 24 can be written as 2 to the power of 3 multiply 3. Therefore, the 3-digit combination can be 2, 4, 3, or 1, 8, 3, or 1, 4, 6, or 2, 2, 6. For the first 3-digit combinations, each set we can have 3 multiply 2 multiply 1 3-digit combination, and because there are three sets of them, so we multiply 3, and that gives us 18 combinations. And for the last one, because there are 2 2s, so we will have 3 multiply 2 multiply 1 divide 2, and that's 3 arrangements. So 18 plus 3 equals 21. Therefore, the 3-digit integer arrangement will be 21 ways. The answer is D. Problem 17. To solve this problem, we need to first write out the prime factors of 360. We can find out 360 equals to 2 to the power of 3 multiply 3 square multiply 5. Therefore, if 360 multiply x is a square, then it has to be 2 to the power of 4 multiply 3 square multiply 5 square. Therefore, we could get x equals 2 multiply 5 equals 10. Similarly, 360 multiply y is a cube. That means the smallest it can be is 2 to the power of 3 multiply 3 to the power of 3 multiply 5 to the power of 3. And that means y equals 3 multiply 5 square equals 75. Therefore, x plus y equals 85. The answer is B. Problem 18. We can see from the graph that when it's a 7-foot by 7-foot floor that is tiled with 1 square foot black and white tiles, the black count as 3 rows and 3 columns, and the white, there are 4 white tiles in every other row and every other column. So if we expand the 7-foot by 7-foot to 15-foot by 15-foot, 15 equals to 7 plus 8. That means we will have 7 rows and 7 columns of black tiles, and we will similarly have 8 white tiles in every other row and every other columns. Therefore, in each row we have the white tiles. We will have 8, and we will have 8 of such rows. So the total number should be 8 multiply 8 equals 64 white tiles. The answer is C. Problem 19. Two angles of the isosceles triangle measures 70 degree and x degree. What's the sum of the 3 possible values of x? Because isosceles triangle has 2 angles that have the same value. Therefore, x can be 70 degree, and another option is x equals 180 degree subtract 70 degree divide 2, and that is 55 degree. And another choice of x will be 180 degree subtract 70 degree multiply 2, and that gives us 40 degree. Therefore, the sum of the three possible values will be 70 plus 55 plus 40, and that equals 165. The answer is D. Problem 20. Because the three vertices of a triangle cannot be all on the top or bottom, therefore, we must have two vertices on either upper or bottom line. So let's assume the two vertices are on the bottom and the length is 1. Therefore, we can have this triangle, and then if we do this, it's the same as the first one. So we have to erase this. And another option is the other vertex is on here. And another option is like this. Therefore, there's 3 options for the bottom length 1. And for bottom length 2, we can have this one and this one. And if we do this one, then it's the same as the first one we have, so we don't count that. And the third one is this one. So again, we have 3 choices. And the last is the bottom length is 3. We can have this triangle, and this triangle. And notice that the third one is the same as the second one. So we erase that. So there are only 2 options. So we multiply 2, and that gives us 8 non-congruent triangles. So the answer is D.